Boys and girls, let's take a look at tonight's homework. There's a little bit of review on integer operations as well as two-step equations. Let's get started right now. Let's look at numbers 3 and 8. We're just dealing with integer operations here. And whether you're dealing with integers or whole numbers doesn't really matter. Once you have operations, you always have to follow order of operations. And order of operations says first check for parentheses. And we've got parentheses here, number 3. I've got 5 minus the difference of a negative 1 and 1. Well, if I've got negative 2 and I subtract 1 from it, it's the same thing as being at 2 to the left of the 0 and then moving 1 more to the left, which gives me a grand total of a negative 3. If I take 1 away from negative 2, it gives me a negative 3. If I owe $2 and borrow $1 more, now I owe $3. It's a negative 3. Any way you look at it. And then I'm going to subtract the difference of that from 5. So I bring this down. I have to bring down that negative because I'm subtracting whatever's inside the parentheses. But now I have a double negative. Okay, if I subtract a negative 3, the only way I can take away a negative 3 is by adding 3. Okay, or another way of looking at it, just logically, the negative or opposite of a negative 3 is positive 3. So now I have 5 plus 3, and my final answer is 8, which takes me to problem number 8. Number 8, again, I have inverse operation. Oh, sorry, again, I have parentheses. I need to follow. I'll get it out eventually. I need to follow the order of operations. Remember, you can always pause, rewind, or fast forward. Inside my parentheses, I have a 5 minus a negative 5 times a negative 6. First parentheses, I've got, again, a double negative. How do I subtract a negative 5? The only way is to add 5. How can I take away owing $5? By giving someone $5. What is the opposite of negative 5? Positive 5. However you slice it, dice it, you're going to get a plus 5. So I have 5 plus 5 is 10. Okay, I took care of the parentheses. I bring down my next operation, which is multiplication, and I'll be multiplying this 10 times a negative 6. And I know when I multiply two numbers that have different signs, this is a positive, this is a negative, my answer is going to be a negative. And 10 times 6 is 60, so my answer is negative 60. Let's take a look at two more integer operations or order of operation type problems, number 11 and number 18. Now, number 11, I've got 2 to the second power raised to the second power. And I know that anytime I raise a power to a power, what I do with my exponents is I multiply them. Okay, so this is really 2 to the fourth power. Okay, so I've got 2 times 2 times 2 times 2. 2 times 2 is 4 times 2 is 8 times 2 again is 16. 16 is my final answer. And then over here, I've got 18 divided by the sum of 2 plus 4. Now, you might say, okay, I have to do division before I can do addition, because those are the operations that we see. But technically, I'm taking 18 and I'm dividing it by the sum of 2 and 4. Not just 2, not 4, but the sum of 2 and 4. So technically, there's parentheses under here, and I really need to figure this out first, what my whole denominator is going to be. And I'd rewrite this as 18 divided by 2 plus 4, which is 6. And I know that every fraction is a division problem, and that 6 will go into 18, because this is really 18 divided by 6. We could write it out like this, 18 divided by 6. But I've got this committed to memory, and I know it's 3. 3 times 6 is 18, so my answer is 3. Okay, let's start some two-step equations. Anytime we're solving equations, we want to isolate the variable. That means get the variable all by itself on one side of the equal sign and have the math junk, the number junk, on the other side, which we can simplify. Speaking of simplifying, anytime before you begin solving for a variable, you want to ask yourself, can I simplify by combining like terms or distributing? And when we look at 21, negative 7p plus 3 is equal to negative 53. The answer is no. There's no simplification, so I can start isolating. The way we isolate a variable is by performing the inverse operations. I can see that p is being multiplied by a negative 7, and 3 is also being added to it. Okay, you first always get rid of what is being added or subtracted to the variable. It's kind of like the opposite of order of operations because we're undoing things. We're peeling all the layers off this equation until we're left with nothing but the variable and its answer or its equivalency. So is anything being added or subtracted to the variable side? The answer is yes. 3 is being added. So what is the inverse of that? If I want to get rid of it, the inverse is -3 or -3. And what I do to one side, I'm going to do to the other side of the equation to keep the equation balanced. My 3 and -3 cancel each other out. I'm going to bring down my -7p, which will be equal to a -53 and a -3, which is a -56. Okay, we're getting there. We're not the variable is not quite yet isolated, but it's very close. There's still an operation being performed on the variable, and it's being multiplied by a -7. So you ask yourself, what's the inverse of multiplying something by -7? Or the opposite, it's dividing by -7. And what I do to one side, I do to the other side of the equation to keep it balanced. So the -7's cancel each other out. I'm left with p on one side, and a -56 divided by a -7 is going to be a +8. A negative divided by a negative is a positive, so p is equal to 8. Let's take a look at 23. Now with 23, it's interesting. The variable is embedded inside of a fraction. And we don't want to keep this fraction here. We can't remove the +7 until we get it out of fraction mode here. And anytime you have a fraction and you want to change it into a whole number, or at least an expression with whole numbers in it, you need to multiply it by its denominator. So what we need to do here is multiply this by a 2. And what I do to one side, I will do to the other side. I need to plug in my battery charger. There we go. Okay, when I do this, that's going to cancel out the 2's, and I'm left with x plus 7 is equal to 2 times 2, which is 4. Okay, what's happening to the variable? It's being added by 7. I want to do the inverse of that, which is subtract 7, and what I do to one side, I do to the other. My +7, -7 cancel each other out. I bring my x down. It's isolated all by itself on one side of the equal sign. And then I have 4 minus 7, which is a -3. So x is equal to a -3. And if I go back and plug this in, a -3 plus 7 would be a +4. And a +4 divided by 2 would be 2. So we can always go back and check our work. Let's take a look at 27 and 35. Okay, first thing we want to do is, can we simplify? And for number 27, we can. We need to distribute this -5 to the v and to the 6, both terms inside the parentheses. That's when we distribute. See, this is a -5 times the sum of v and 6. We can't combine these two terms because we don't know what v is, but we can distribute. So I'm going to get -5 times v will be a -5v, plus a -5 times 6 is going to be a -30. It's equal to a -60. Now I can begin to isolate my variable. Is there anything being added or subtracted to the variable side? The answer is yes. I'm adding a -30. Well, how do I get rid of a -30? By adding 30. Okay, a -30 and a +30 will cancel each other out. What I do to one side, I need to do to the other. My -30 and +30 cancel each other out. I bring down my -5v is equal to a -60 plus a +30, which will give me a -30. One more operation to take care of. V is being multiplied by a -5. What is the opposite of that? Divide by -5. What I do to one side, I'll do to the other. My -5's cancel each other out, and I'm left with v is equal to a negative divided by a negative, which is going to be a positive, a -30 divided by a -5, which is a +6. So v is equal to 6. Let's take a look at number 35. Now, 2 problems ago, we had the variable that was embedded inside of a fraction. This isn't the case. Here I can get rid of the -7 first because it's all by itself. It's being added on to this fraction. It's not one big complex term or fraction. So I can ask myself, is anything being added or subtracted on the fraction side? And the answer is yes. 7 is being added. What is the inverse of that? Subtracting 7. And what I do to one side, I'm going to do to the other. The +7 and -7 cancel each other out. I bring down my r divided by a -2. That's correct. Some of you might be saying, well, that's r -seconds. Yeah, but every fraction is a division problem. And a +17 plus a -7 or -7 is going to be a +10. Okay, we want to isolate the variable. What's happening to the variable? It's being divided by a -2. What's the opposite of dividing something by -2? Multiplying it by a -2. And what I do to one side, I do to the other. Okay, so the -2's cancel each other out. I'm left with r is equal to 10 times a -2, which will be a -20. R is equal to a -20. Well, hopefully, boys and girls, that was more fun than a barrel of monkeys. And if it wasn't, hopefully you learned a few things. And if you have questions, please bring them to class tomorrow. I'm a good math teacher. I'm just a lousy mind reader. I'll see you tomorrow. Bye-bye.